Cauchy's theorem is really straightforward to prove. It says if f of z is holomorphic inside and on a simple closed contour gamma in a simply connected domain, then the contour integral of f of z along gamma is 0. That is, the integral of f of z is 0. So it doesn't really matter the size of the loop or anything. It's just going to be 0. Okay, so these are basic assumptions. Z is x plus iy, f of z is u plus iv, and a change in z always comes from a change in x plus a change in y. Because it's holomorphic, we're assuming it's holomorphic, we can assume the Cauchy-Riemann equations hold. And then we're going to use Green's theorem. That's really what's going to make this proof happen. And so this is Green's theorem. I'll put a link to my derivation of Green's theorem in the description if you're interested in that. So let's get on with the proof. It happens fast. So we take the integral of f of z, and f of z just becomes this, dz becomes this. And now we're just foiling this. That's all this is. And next, all we're doing is collecting the real parts into one integral and the imaginary parts in the other. And now this is where we're going to use Green's theorem. So if we look at this and think about this, so P basically is U. And so this term becomes negative and comes over here and becomes partial with respect to whatever the other thing is that's not this. And so this here becomes negative, goes here, becomes partial u partial y. This keeps the sign it had, comes here, and becomes partial b partial x. So I had the dy, so it does partial x. And this comes over here, becomes negative, and becomes partial b partial y. This comes down here, keeps the sign that it had, and becomes partial u partial x. And now these are both 0. Notice we didn't talk about the actual integral or any bounds of integration or anything like that. It doesn't matter because when we look at both of these terms, they go to 0. I copied the Cauchy-Riemann equations down here again just to, for quick reference. But looking at this, it almost matches what we have here. If we take this and put it on the other side, and now that's 0, we can see that's 0, so that goes away. And this is this, and this is this, so anything minus itself is 0. And so this goes to 0, and there we go. We have proven Cauchy's formula or theorem.